Assalamu alaikum. Today we will going to present about DFS algorithm. I myself Mahfuz Ahmed Nirob and my teammate.
Is PRITOM. Sir, we will continue the presentation all through. Hope you will like that.
So, what is DFS? DFS is an algorithm for traversing or searching a graph data structure. The algorithm start at the root and explore as far as possible along each branch before backtracking. In other words, we can say that this is an algorithm that search as deep as possible first. So the basic idea from this understanding we can get that we will start from a root or any arbitrary node and mark the node and move to the adjacent unmarked node. And this loop will continue until there is no unmarked adjacent node. Then backtrack and check for the unmarked node and traverse them. Finally, print the node in the path and we will continue the DFS algorithm. Color representation. While doing this DFS algorithm, we need to understand the color algorithm that is going to happen here. First of all, the initial state, the white color. This represents the initial state where we will start the algorithm and before that it will remain as white. Then when we start the algorithm and start to discover it, then the color will turn to gray. And finally, when there is no node where we can traverse and we have to stop there, which means the vertices are fully discovered, then we will turn it black. And when we see all the vertices or the node that we have traversed turn into black, we will understand that the DFS algorithm has been finished. Now, my teammate Pritom Dhar will make you understand about the stimulation of DFS algorithm.
In the above stimulation, as there is no source, we take a random source and the node is A. Firstly, the color of the node will be white. We start from node A and set 1 as its discovery time, causing the color of the node turning into gray from white. Then we traverse from node A to node B and node C, putting 2 and 3 as its discovery time. So now the color of the node B and C also becomes gray from white. As there is no way of traversing in node C, we set the finishing time 4, causing the color of the node becomes black. Now after node C, we traverse in the node D, setting 5 as its discovery time and causing the color becomes white to gray and 6. As its finishing time causing the color turns into black. As there is no other way of traversing, backtrack to node B and set 7 as its finishing time. For this, the color becomes black. Now after node B, we visited the node E and F, putting 8 and 9 as its discovery time. And as well as color turns into gray from white. And we put 10 and 11 as its finishing time. And the color of this node becomes black. In node F and H, we took F as its first traversing node, putting 13 as its discovery time, and color becomes gray. Again, we then traverse to node H, putting 14 in its discovery time, and its color becomes gray as well. Lastly, in node H and F, we put 15 and 16 as its finishing time, as overall the color becomes black in all the nodes. This stimulation causes the color of all the vertices turns into black from white and as it is finished discovering. Then if we implement this stimulation into a tree, it will form a multiple tree, that is forest.
So let's understand the pseudocode of DFS algorithm. First, we will take any random source from where we will start our traversing and make all the vertices color white and making the predecessor null. Then we will take the global timestamp and make it 0. Then we will call DFS visit whose vertices are all white and from the random source. The vertex we call DFS that we will turn into gray color which has been discovered. Then we will increment the global timestamp by 1 and set the discovery time. For each vertex we call DFS which are adjacent, and if the adjacent of the vertex are white, then again we will call DFS visit. Now we break the loop which causes the vertex color turn into black, which means that each vertex of the graph has been discovered and our DFS algorithm has been finished, and we increase the global timestamp plus 1 and finish the implementation. To understand the time complexity, we can again start from DFS code where we take a random vertices. From line 1 to 3, there is a sort of loop. This part make the vertex color white and make the predecessor null, and for that the time complexity is order of V. For line 4, where we put the global timestamp is equal to 0, here the time complexity is order of 1. And from the line 5 to 7, there is also another loop which represent the norm of vertices. So here the time complexity is order of V. And for the DFS visit part, here the same thing has happened as which has happened in previous line from 5 to 7, where we told that there is a loop occurring that represent the norm of vertices and called DFS visit. Here the same thing occurring where the color is changed from white to gray when it is discovered, and the time complexity is increasing from 1. And if there is any white color vertices, it is again revisited. So it can be said a reciprocal action or a recursively call action that is happening as the previous part. So here the time complexity can be said as order of E.
If we sum up all the time complexity of the pseudocode that has been described, the total time complexity will be order of V plus E. Thank you.
I hope you like our little effort, and thank you very much. Assalamu alaikum.